Acidius Academy back here with physiology, and we are looking at dehydration. Now, this comes from cellular fluids, and just to help us recall, for a 70 kg old man, this is a man. For a woman, it might be different. So, when you're talking about the total body water in a 70 kg man, total body water is 60% of the body weight. Now, since this man has got 70 kg, then the total body water is going to be 60% of 70 kg. So if we get to do that 60% of 70 kg, that is going to give us 42 kg. But you know that the density of water is 1 kg per liter. Then if you have got 42 kg, that means you also have 42 liters. So this is the total body water in a 70 kg old man. So if it was a woman, the total body water is 50% of the body weight. So we would have used 50 there. Now another thing that we know is that the intracellular fluid volume is 40% of the body weight. Now since we're talking about a 70 kg old man, then this is going to be 40% of 70. So 40% of 70 is just 40 out of 100 times 70. And this is going to give us 28 liters. Now when we get to add the extracellular volume and the intracellular volume, we're supposed to get the total body water, which is 42. Meaning that if I want to find the extracellular volume or the extracellular fluid volume, I'll just say 42 minus 28. And that is going to give us 14. Or we can say ECF, which is the extracellular fluid volume, is actually 20% of the body weight. So this is going to give us 20% of 70 kg, and that is going to give us 14 liters. So when you are talking about an average man, a 70 kg that we're discussing for now, the extracellular fluid is 28 liters, and I mean the intracellular is 28 and the extracellular is 14 liters. Now when you are talking about dehydration is simply the loss of water. So water in this regard, when we are talking about its loss, then we are going to be losing from the extracellular fluid. Because if you consider a man, just a person, so when this person is to lose water, they are going to lose water from maybe their blood, that is plasma volume, or they are going to lose from the interstitial space. So the water will not be lost from the cells. It is when the water is lost from the extracellular space, then that is going to affect the water in the cells, and the water in the cells is now able to migrate like that. So when we are talking about dehydration, we are talking about the loss of extracellular fluid volume, and what that is going to affect the intracellular fluid volume, right? So the first one is the isotonic dehydration. Now the word iso means same. So isotonic dehydration is losing water that has got the same concentration as the concentration in the cells. Remember, we are saying the loss of this fluid or the loss of this water is supposed to be from the ECF. Now we've already determined that ECF is 14 liters. So let's say this is the ECF and this is 14 liters, that portion, and then the other portion, that is ICF, which is 28 liters. Okay, this is ICF and this is ECF. Now what happens when you get to lose water? So when you have got a normal person, the whole of this is going to be completely filled up from the ICF to the ECF like that. The fluid completely fills up. Now you have lost water from the extracellular, that is isotonic dehydration. So instead of the ICF compartment being completely filled, you are going to lose some water. Okay, you have lost some water, you have got a space that has remained. Now, since the water that you've lost from ECF has got the same osmolarity as the water in ICF, so what I mean by osmolarity is simply it has got the same osmotic pressure. In other words, the same concentration here is the same concentration here, right? So meaning that the water, if you've lost water that has got the same osmolarity as the osmolarity that is in ICF, what is going to happen is that there is going to be no movement of water from here, because water moves by osmosis because of difference in concentrations. So the concentration here has remained constant. Actually, when I'm talking about concentration in this case, the concentration that we're going to take for each cell basically is about 300. So that is the concentration in ICF and the concentration in ECF, and it is the same in both. Right, the concentration is constant in both compartments. So the fluid that you've lost here has got the same concentration as the fluid that is inside. In other words, there is no dilution of whatsoever. So the effect of that is the concentration in the cell is just going to remain the same. So you have lost some water from the extracellular fluid, but that doesn't affect the concentration or the fluid inside the cells. So basically, when I'm talking about isotonic dehydration, what goes to happen is the osmolarity is not changed. So the osmolarity is constant, it's not changed. The volume of ECF is going to decrease. Okay, so the volume of ECF decreases, and also the arterial pressure decreases. Apart from that, there is increase in plasma proteins. Now, why would the plasma proteins increase? So the reason as to why there is an increase in plasma proteins is because you have lost some water here. You've also lost some fluid, right? You've lost some water and also lost some fluid. Now, just inside the blood, we also have proteins there, right? We have got proteins. Now, because you have only lost ions and water, what is going to happen is that the plasma proteins are still there in the cells. So they are going to be much higher as compared to the way you consider them when you add a lot of water. Okay, so that is why we are saying there's an increase in plasma proteins. Not necessarily that you have increased it, now it's because you've reduced the water. All right. So another type of dehydration, well, before we get to come from this one, we need to know also examples that can cause isotonic dehydration. How can you lose water but water is not coming from your cells to the extracellular fluid? Examples of this include diarrhea, vomiting, burns, and hemorrhage. So these are some examples. Vomiting, so when you get to vomit, you are going to lose water and also together with some ions, right? So it doesn't select, unless in some types where you just get to lose water without ions, but most you are going to lose ions and water. That is why that is going to be isotonic dehydration. And also when you have diarrhea, right? So we now talk about hypertonic dehydration. Just from the word, let me start with hypotonic instead of hypertonic. I'll put O there. So from the word hypotonic, hypo means lower concentration as the concentration inside the cells. So here you have got the intracellular fluid, here you have got the extracellular fluid. So you have lost water and the concentration in the extracellular fluid is now less than the concentration inside. That is why we are saying hypotonic. So the concentration in the extracellular fluid is now less than the concentration in the intracellular fluid. What will be the effect of that? Since here the concentration is reduced, or osmolarity, if I say concentration, all I'm saying is osmolarity. Osmolarity is simply concentration. So osmolarity has reduced in ECF. Now, so since here the concentration is about 300, maybe let's say here is now 297. So what is going to happen is that water always moves from a region of lower concentration to a region of higher concentration. What do I mean? When we have got a high concentration here, for example, you have got a lot of sugar, you'd want to dilute that sugar. So that is why water is going to move to a region of higher concentration, right? So where there is reduced concentration or where there is low concentration, there is a high water potential. In other words, there is more water as compared to ions. So water is going to move to where the concentration is high because water potential is low, or there is low water for there to be high concentration. So because of that, what you are going to be able to see, so the diagram is going to change, is going to look something like this. So why does it get to look like this? You had lost some water from the ICF, and the water that you lost, you have an hypertonic solution, meaning that the water that you lost had more ions, right? You lost a lot of ions. Because you lost a lot of ions, you ended up with a solution that has got a lower concentration, and that is what we are calling hypotonic concentration, right? And that is hypotonic dehydration. So you lost more ions as compared to water. So because the concentration has reduced here, or the number of ions has reduced, and you have got a lot of water, water to ion ratio is high, the water starts moving in that direction. So the net flow of fluid in hypotonic dehydration is from ICF, from ECF to ICF. The water is going to move from ECF to ICF, right? So this is what gets to happen. And examples that we can talk about when we talk about this kind of dehydration is sweating. So when we get to sweat, I think we've also experienced it, that sweat smells salty. That is because we've lost ions or body electrolytes, right? Sweating, and also adrenal insufficient. So if you have got some adrenal insufficiency, in other words, an example of I can give of this adrenal insufficiency is aldosterone. So aldosterone is the one which is responsible for reabsorbing ions back in the kidneys. Now, when this is insufficient, it means the ions are not going to be reabsorbed. Because of that, you are going to have a lot of ions being lost even through urine, like that. So because of that, water is going to be moving from the extracellular fluid to the intracellular fluid. What happens is that the cells will start becoming bigger. They'll start becoming bigger and bigger, like that, right? So this is what gets to happen when I'm talking about hypotonic dehydration. Water is going to move from ICF to the inside of the cells, and water's movement to the inside of the cells will make the cells to expand, right? And the last one, the last type of dehydration is hypertonic. Now in hypertonic type of dehydration, the ECF volume, or the fluid in this ECF, is going to have a higher concentration. And the reason for that is that you have lost a lot of water. Okay, loss of a lot of water as compared to ions. Because you have lost a lot of water, it means you have got more ions that have remained, right? Because the water ion ratio has been increased. So you have got a lot of ions which have remained because you have lost a lot of water. So the concentration of the ions becomes higher, because concentration is number of moles of solute over volume of solution. So because the concentration here has become higher, water will start moving in the direction of higher concentration. So water is going to be lost from the intracellular fluid, and it will be going into the extracellular fluid. And so what you are going to have is something like this. This is how the diagram gets to look like. And so this is what you are able to notice. By the way, when you get to increase fluid in the extracellular compartment, you are going to have edema, where you get to swell. You start swelling. For example, if you've been standing for a long time, you start sweating because there is an excessive increase of fluid in the extracellular compartment. Right now, I'm not talking about edema. So basically, this is what is happening: loss of water from the intracellular fluid to the extracellular fluid, because the fluid in the extracellular compartment has a higher concentration. And examples we can give of this is diabetes insipidus. We can also, so when you're talking about diabetes insipidus, this is just an excessive loss of water. So there is an excessive loss of water that can be also due to ADH insufficiency, antidiuretic hormone. So antidiuretic hormone is the hormone that is responsible for the reabsorption of water in the kidneys. So if the kidneys cannot reabsorb water because there is an insufficiency of ADH, then you are going to have hypertonic dehydration. Well, thank you so much for watching this tutorial. Stay blessed.